So how is everybody doing there? Hope everybody is doing good and well. So we'll start today's session then. I just try to give more real-time, examples, more real-time scenarios where we can implement our new topics or new, technologies, whatever we are learning. I mean, it's good to know some basic theories, what is going on around. So just what is Azure function is like, it is serverless. We have discussed that it's complete abstraction. So as a developer, you don't have to worry about, maintaining your hardware and scaling. We have seen, all these things were already there with your app services also. Like your website, what you're publishing, your web application, what you're publishing. Like it was also very similar. Like you don't have to worry about your hardware. You don't have to worry about scaling. Like you can do manual scaling and auto scaling. We have seen. A different thing about this functions is like you pay per use. Like we have seen, we went to Azure price calculator there. Then on that website we have seen, like if you are calling 1 millions of one millions of calls per month, they are still free for us. And after that, even if you make 2 millions call, like the overall charge was less than $3 per month. So cost wise this is most budget and economical. And you might have also heard this term, like function as a service. So we have seen, we discuss infrastructure as a service, platform as a service, software as a service. This is like your function as a service, because your function is going to do just one task. The responsibility of your function is to just do one task and do it good. These are some characteristics. This is single responsibility because it does one task. The execution time is also less and stateless. Anyways, like all your web application or HTTP is stateless. And it is event driven. We have seen HTTP trigger, we have seen Cosmos trigger. Basically, these functions get executed based on some action. If it is an HTTP, you either have to make a GET request or post request in order to invoke that function, or if it's a Cosmos DB or storage blob, Cosmos DB trigger or storage on blob or queues, all those get triggers based on some action happening on those resources. So this is pretty basics about it. But with our current knowledge and what we have seen in last 2 days, I cannot handle this situation. Sequential execution. Just imagine that this is my scenario. This is my e-commerce site, and I have to do 3 activities or 3 operations or 3 tasks when an end user submits an order. First thing, I have to make sure whatever the payment information is giving or entering into our website is valid and I can charge his credit card. Basically, I need to integrate with payment gateway. Next, once the payment is approved or rejected, but I have to complete this task. So result might be anything. It might be pass or fail, but I have to complete this task. Once this task is completed, most likely it will pass. Then I have to generate a PDF and store that PDF in my blob storage for my future references. Okay. This is my second task. The third task is, after I generate this PDF, I have to send an email to the customer with as an invoice of that PDF. So these are 3 activities I have to perform. But if we look at this logically, I cannot generate invoice until and unless the payment is confirmed or if the payment is completed. Similarly, I cannot send an email until and unless a PDF is generated, and this will get generated only if the payment is successful, or if the payment is failure, I still need to generate some kind of receipt saying that your payment was unsuccessful or something. But I have to make sure that the function 1 has to complete before calling function 2, and similarly function 2 has to complete before I call function 3. So this is my requirement. With our current knowledge and whatever we have seen with Azure function, we cannot achieve this. There is no sequential order. Right now what I can do, I can create an HTTP trigger function and share that HTTP trigger function with my payment gateways at webhook. So this is one function I can do. So to generate a PDF, I can write another function. And to send an email, I can write another Azure function. But how do I control which one get execute first and which one get execute to? That is not available right now. To address this problem, Microsoft, what they have is they have something called durable functions. These are nothing when you have the same Azure functions. On top of that, they have built an additional extension to achieve this scenario. Okay, so those are called durable functions. So there are few terms and terminologies for this durable function. One thing is like it's a long running, it maintains the state, and you can simplify complex transaction, or you can link the complex transactions. Like this is a transaction, right? You make a payment, then you generate an invoice, then you send an email. Another example might be like an employee might be applying for a leave. So his immediate supervisor might need to approve it. That is one step. After that, it might get forwarded to the manager. He needs to approve this. Then it will get forwarded to the HR department. They need to approve it. So like this, wherever you see a transactions, a series of activities which are dependent on each other, related and dependent, then we have to use something called durable functions. Okay. So for that, they need to maintain the state. We can do it locally. And all this can be done in C#. Okay, so just try to understand what is durable function. These are an extension on your Azure function or enhancements on your Azure function to achieve these kind of scenarios where you have to run your Azure function in a sequential order. Any questions till now? They are just called durable function. Is there any category called durable function? Yeah, like when you create new Azure function, you'll see a category there called durable function. We just see that right now. Okay, so we'll see how to do that practically in C#. But before going to that, did you understand why do we need it and what it is and how it is going to help us in our current project or in our real-time scenarios? Everybody good? Everybody on same page? Okay, good. Okay, before we discuss this durable function, like with our knowledge of .NET, with our knowledge of web application development, and with our knowledge of what do we say, with our experience, how do you achieve this one? Suppose this is my requirement and think that you don't have durable functions. How would you achieve this one? As a developer, as a project manager, or as a with all your experiences, how would you solve this problem? Does anybody wants to give some answers here? Just think that we don't have durable function concept and this is my requirement now. What will you do? I'll create a table something like this. First, I'll keep a track of what are the functions I need to execute, right? And I'll keep function name here. And this is a rough idea I'm just giving. And it doesn't mean that this is a perfect solution. I'm just giving a rough idea so that you just get an idea, like how do we achieve this. Definitely we need some temporary storage to track the status here. Okay? Status of this running or something. After certain time, when the execution is completed, you will change this to completed. Maybe the final is still running. Okay. Then overall there should be one function, one main class or main to keep track of what is going on under this. So this is something like we can just sit and discuss and finalize the design and come up with the final perfect solution. But the solution will be on the similar lines. Like you might need to use some temporary storage. You might need to maintain the states of each and every function. You might need to maintain the status of each and every function, whether it was completed and whatever the output I'm going to get it from this, I will need to pass here. Or you think like this is not a perfect solution, but I just wanted to give you, an idea like how would you design it, and we can design a perfect solution, but it would be on the similar lines. Okay, agree? Okay, good. So if you go back to this PowerPoint slide, this is what your durable function is doing. This is exactly what they're doing. There is a main function. They're maintaining a temporary storage and they're maintaining the list of all the functions what they have to execute, and they're maintaining the status of each function. Okay, we'll see how they're doing it all. Okay, that's all. Internally, they have written an extensions on an Azure function within the C# and they just upgraded that, enhanced it. So good thing is we don't have to do all these things. I don't, as a developer for my web application, for my e-commerce application, I can concentrate on my business domain, my requirement. I don't have to worry about all these things. Okay, this will be taken care by this additional extension, the NuGet package, which we might need to install there. Okay. So basically there are three functions, three components. One is to start the main function. There is a starter function, there is an orchestrator function, then these are the activity functions. So in this scenario, if I go back, there is one function which start this workflow, and that function is called as starter function, which actually initiate, or you can call this as a trigger. Okay, and mostly 99% of the time it would be an HTTP trigger which start this function, and this function, orchestrator function, this is a main function who controls the execution of your all the activity functions there. So we just need to keep, same thing happening what we just discussed roughly, but there is some terminology, like you just need to keep in mind what is starter function, what is orchestrator function, and what is activity function. Okay, so we'll see what each of this function does. So this is an example code of an orchestrator function. So what orchestrator function does is it manage all the activity functions. So F1 is one activity function, F2 is one activity function, F3 is one activity function. If you see in this example, this will be initiated or this will be executed by your starter function, and after that starts, first thing what we are doing is we are calling a function F1, and the result of that we are storing into X. Okay, and then we are calling F2, we are passing the result of F1 as X to second function, and whatever the result we are getting from second function we are storing into Y, and we are passing that Y into the third function. So there are two things in here, like we are executing all these activity functions in a sequential order, plus they are dependent on each other. My F2 depends on F1, my F3 depends on F2, because the output of one function is acting as input into next function. They are not only executing in sequential order, but they are also dependent on each other. So this is how we can solve this problem. So they are related and they are dependent and they are sequential execution. Okay, we'll see one example. So how they are able to achieve this? Same thing. Internally, they are maintaining a history table. So whenever an orchestrator function tries to execute this first call, what it does is before executing, it will check that history table, whether did I execute this function. If the result is no, then it will execute the function. It will queue that function into the history table to start the execution, and execution starts. You'll see the rows like this adding into the history table. When the execution completes, you'll see something like that. Execution gets completed. The next time when orchestrator's function start to execute, because we have already executed F1, we see the result there. So now what it does is, it doesn't start from F2. It again goes back to F1 and try to execute that. So before executing that, it will check whether did I already execute this? Yes, we did. So it will skip that one and execute the second function here. So okay, that is pretty much it about the PowerPoint. If you have any questions in last 2-3 slides, I'll try to explain, or we'll go to the practical scenario and we'll see the history table and we'll see all this step by step. Okay, good. So let's see this in an execution. So that will give us more exposure to this. So I'm just adding a new project to the same solution what we have been using here. Same Azure function. Let me call this as durable test. They have added this durable function orchestration recently, but good thing is with the latest updated Visual Studio 2019, you have this category here, okay, durable function orchestrator. So see, they're saying that some like it is going to use a temporary storage, so it needs a storage account to maintain that history table. So we are using a storage emulator, the local one for us. It would be running something like this. Once you run this storage explorer, it will be running locally in your system. So meanwhile, let me just, okay, it is generating the code here. It's done. It's restoring the packages from NuGet. Just wait for a minute here. Azure functions were formerly known as web jobs because these are kind of cron jobs or scheduler jobs, so they were actually referring it to as web job, but recently they renamed that to Azure functions, but internally the namespace are still web jobs, and durable functions are extensions on your web job. So all these NuGet packages and all were added by your Visual Studio for us because we use that durable function template to create this boilerplate. Okay. So let me just minimize all these things. So this is a startup function, and it will be an HTTP trigger function, meaning that somebody has to call this either on get or post if they are passing some data to initiate this workflow. In our scenario, what we will do, we will share the URL of this startup function, or we'll add the URL of the startup function as a webhook to our payment gateway. Once the payment is completed, success or failure, we just have to make sure it is completed. That payment gateway will call this HTTP. In our example, payment gateway will call this HTTP URL, and this HTTP URL, what it does is, it will start your orchestrator function. Starter dot start the sync. What is function 1? This is your startup function. It says run orchestrator. So what is the name of the function? Function 1. So starter function is like it just only execute in the beginning of your transaction. The responsibility of the starter function is to start orchestrator function. Now this is the main function which take case of managing all your activity functions. So how many activity functions we have? We have one starter function, we have seen this. We have one orchestrator function, we have seen this. In this example, on the boilerplate which it is creating, it has just given one starter function here as, one activity function as function 1. If you see the code here, in your durable function, you are calling that activity function thrice. The same function it is calling thrice, just for an example. But we can have multiple activity functions here. So in this sample code, they are calling the same single function 3 times with different parameters. What it is doing, they are just logging the information on. First time they are passing Tokyo, second time Seattle, then London. So let's just execute this one and see what is the result. Let's change the start function here. Okay. At the same time, I have opened this Storage Explorer. Okay. Under Storage Explorer, you should have this, executing here. Storage emulator. If you just run this program, or if you run, you either have to call it like your third-party application would initiate that startup function, or you manually, like if it is your application, you manually call that HTTP URL either from client side AngularJS or React, or from your C# or jQuery or somewhere. It's an API call. Okay, let me just run this. So why I'm running this is like sometimes you'll not see this emulator here, because once I run this, it might start emulator. Then we should be able to expand this local and attached, and under that storage account, and under storage account you will see something called emulator. So you expand emulator, and under tables you should see these two tables, okay, instance name and history name. So your durable functions are going to use these two tables to maintain that state, what we have discussed roughly in this Excel sheet. So this is your starter function, this is the URL. When this is hosted now, it is ready to be called or ready to serve the client. So it is hosting locally on our emulator now. This is the starter function, and this is the orchestrator function, and this is the activity function. So we just have one activity function, but we are going to call this same activity function thrice with different parameters there. Okay. So how do I initiate this?
Yeah.
Okay. So I'll just copy this URL and I'll paste and go here. Let me do one thing. Let me just put a breakpoint. I'm going to put a breakpoint on second call. Okay. Right now, all these tables are empty. I just removed all history records, I mean previous records here. So there's nothing here. Let me go to this browser, paste and go. So it is going to start your startup function. And that startup function is going to execute your orchestrator function, and we put a breakpoint. So we should see some records here once this is being called. Sometimes, right, if you click on this console, it will stop executions there. So sometimes you have to hit enter to continue that. Anyways, like if you see in logs, HTTP startup function, then F1 is your orchestrator function, and F1 underscore hello is your activity function. So it has executed, it has executed the function with Tokyo the parameter. So if I go to storage and just refresh, so this is the instance, this is kind of a main function or main table which keep tracks of what is happening. If you see the current status of that request, it is running. So this is what I was trying to say. Long running app. This execution, what is in progress, can last for a long time, for an hour or for 2 hours, and that the state is maintained under this storage tables. It is running. If I go to his history table, I see some transactions here. I see some rows here. Orchestrator function started. It has also started executing our hello underscore one activity function. So I'll just do F5. So what it does is now it is trying to execute the second function now. So I did F5. It just executed the first function in the first run, and in second run it went back to the history table. If I just refresh now, I have more rows here. It went back to the history table and it checked that, oh, hello one function was already executed with that parameter. So you got that result as hello Tokyo. Now it is trying to run the second function. So if you just do F5 again, so it called that function thrice and it called it in sequential orders. So if you just refresh this, so hello one was called first with hello Tokyo, hello Seattle and hello London, and finally what we are doing here is it's just returning the complete output. It's not necessary, but just to log everything is completed, and in that sequential order we just got same thing like hello Tokyo, hello Seattle and hello London. Okay, any questions on this? We'll see one real-time example, but I want you people to implement the internal code. Okay, before that, any questions in this? Let me add a new function here, new project. Next, let's call this as checkout, because we need a workflow for our checkout process, which can have multiple activity functions there. So in our scenarios, we may have 3 activity functions there. I just want to rename this function. And if I go to the startup function, this path is not looking good. If I have to share this path with the vendor or the business to business communication, so I have to give something meaningful here. I'll say checkout starter. What it does is it will start your checkout function. So I'm going to change this because it was calling F1 in the beginning. What I did, I just renamed the starters function URL and I renamed the orchestrator function name to checkout, and I'm passing that checkout function name into the starter function here. Okay, so your starter function is ready. It is going to listen on, get and post. Again, this authorization level is the same, like we are keeping anonymous, but I can keep function and share that URL key, that what we have seen in the yesterday's example or day before yesterday, but let's keep it anonymous in your local activity function. Let me do one thing. Let me add a sample model here. I have that one. I just want to demonstrate some complex object. That's why I'm taking a sample object here. We change the namespace. Okay. Just think this is your complex object. For now, we are just passing two properties here, ID and description. What I want to do is I want to pass this object from one activity to another activity. The result of this might be passed to this one, and we can share the same object across multiple activity functions. So we're going to use this namespace, this model class that I have created here. And we need to create activity functions here. Okay, I've just removed that existing activity function. So I have the code here. I will just use it, and I'll explain you the code. It will save us some time for typing. Okay, one activity function, three activity functions. I just copied here and put it in our class. So now I have three activity functions. One is for payment gateway. I'm calling it as payment gateway. Another is like generate invoice. Another is like emailing the customer. So this internal code, I want you people to try out. Like if you cannot work with a real-time payment gateway integration, just try to write some record to that Azure table or Cosmos DB something. Then make sure that you're passing data. Same thing. Internal code, like you people know C#, you people know your experience. You can write that code, but I just want to demonstrate this durable function concept, how we can call and pass data between different activity functions here. So pretty simple. I'm just taking the sample object and I'm changing the description, payment completed successfully. Then I'm changing in this generate invoice generate successfully, then email sent to customer successfully. So if you come back to the orchestrator function, we need to call this here, right? Let me just take that code also. Okay, this one I'm just initializing that this sample object with ID as view ID and description as starting payment gateway integration. Okay, this is simple. We have that. Okay, now I'll close this one. We have that model class here. I'm using that model class to initiate this properties. Okay. I want to pass this property to payment gateway. So this might be a complex object where you want to pass your credit card and expiry date and CVV along with your shipping address, all those things. The complete object you might be passing it to the payment gateway here function. So what this activity function does is internally they does something, and after that it is going to change the description of this object, the same object we are passing here. It is going to change the description of that object and return that object. Okay, that object, whatever the return value we are getting, I'm still keeping it in the same variable. So I'm passing the same output and changing the value and storing it back into the same variable. Okay, for log purpose I'm adding it here, otherwise this add to output is not important. This is not important, but just to see in the logs I'm just adding it. Same way, the output of my payment gateway function I'm passing as input to the generate invoice function, and the overall the result of this I'm storing it in same complex object. So what it does is it will override starting payment gateway with whatever this first function is returning, because you're just saving it in the same variable back. Next thing what happens is the payment completed successfully get replaced by invoice generated successfully, and this get replaced by email sent to customer successfully, but ID remains same. We are not changing the ID. I'm not changing the ID to just make demonstrate that the same object is passed between multiple activity functions, and it can share the data across multiple activity functions. Okay, so let me go back to the storage and just remove these rows here, and let me just keep that row. I'll just remove it from history table. Oh, we are running durable test function. That's the reason. We have to run the checkout function. We run that old project. That's why we were getting that old URL. So we have to run this checkout project. We should see all the new URLs here, whatever we have overwritten. The starter function URL should be something like this, checkout starter, and orchestrator function and all these things should be displayed here. Okay. So this is the URL for starter function. We have renamed it to checkout starter. So this would be like if you deploy this on your Azure, this will be your project name.azurewebsite.net, that domain, and after that this will be API / the name of their starter function, whatever you're giving here. Okay, under that orchestrator function is checkout. That's what we have given in the beginning. Name. Then we have three activity functions. Activity trigger, email customer, generate invoice, payment gateway. So this is getting displayed in an alphabetical order like C, then D, E, F, G, then P. So that doesn't mean that it will execute in this order. It will execute in the order you specified in the orchestrator function. Okay, let me take this URL and I'll put a debug point here. We call this placement flow. So it has started the execution. Like you can just keep a track of log also. In development environment, you can see log, but in real-time environment, what you have to check is you have to check these tables, history table, to keep in track. How do you check this history table? You don't have to write code also. Like if you once you started executing this, it is returning some URLs and APIs for us. So the status query URL. So this is important for us. If I just take this one, the first one, I'm taking this, expand this, zoom out. I'm taking this URI, status query URI. I'll open a new tab and call this here. Because it's in debug point, it's not showing. If I just execute this, it should show running the status here. I'll just execute this one. Let's see now. Okay. It's showing because we called this URI when the orchestrator function or your durable function was running. The current state of that function was running. It was showing. It is showing running here. Now if I just call it again, it should say completed. Okay. So if that was a long running task and you want to check the status, this is the URI you have to check. Okay. You don't have to go to table or you don't have to write the code to check the status of your long running durable task. You can use this function. It gives the complete details, like what is the instance ID, should be the same ID what we should see here in this instance table. Another thing what I want to show was that we are passing same ID. This is the instance ID, A, something like that. This one. So it started the orchestrator function, then started payment gateway, then it executed generate invoice, then it executed email customer. If we see what is the data we have passing in between here. So first we say, you see the GeoID 43E5. The first payment gateway when it is completed, task completed. This started here and completed here. So when it is completing, it is changing the description. We are not changing the ID. If you see, we are sharing the ID across multiple activity function, and still we are able to change the other property. Like here I change the description to invoice generate successfully, and here we change the description to emails sent to customer successfully, and finally the ID is still same, description is different. So if you see this, okay, let me click on edit. Set result. Okay, get it here. This is one. Then this is one, and this is your third object. This is what we have been adding it to the list of output, and finally we are returning that. So that is getting logged in your last step here. Okay. So that is what we wanted to discuss today. I've seen this one, those API URLs, and okay. So any questions in this? Any questions in this PowerPoint, or any questions in what we have seen? See, this code you people can implement. I mean, plain C# code, how to integrate with payment gateway, how to generate invoice, like basically how to generate a PDF and how to send email. All these codes people should be able to do it based on your current requirement of your project. Only thing to keep in mind here is, like, there's a startup function. This will act as your HTTP trigger function, and this URL you have to share or internally within your project or with a different team. Like, this is the one you have to share. And one orchestrator function, the responsibility of our orchestrator function to keep track of all the activity function and the execution and the state of that. So that is what your durable function is. With the help of durable functions, you can achieve these kind of scenarios. All right then. Have a nice day or nice evening there. We'll continue tomorrow on this.